Hey there guys, for today's video we are going to talk about Excel functions that work under the profession of accounting. So for the first formula we have the NPER. NPER stands for number of periods, by which we calculate the number of periods or number of payments that we need in order to pay off a certain loan. So to further demonstrate, we have here an example. So for the rate we have 0.05, which stands for 5%. For the payment, we have 200, which is valued at a negative because payments of loans are an outflow for us, of course. So next one is the present value at 8,000 and the future value at 10,000. So let's try to compute this using NPER. So simply we need to type the NPER formula and then open parentheses. So as you can see in here, we have the rate, the payment, the present value, and the future value, which surprisingly it matches with our given. All we need is to put all of this into the formula and then we'll calculate the value. So for the rate 0.05, then of course we need to divide it to 12 because it is when we talk about loans, we are talking about monthly basis payments, not annual basis payments. So we need to divide it to 12. The next one is the payment, which is negative 200. B4, present value at B5, and then the future value 10,000, and that's it. So as you can see, we have computed a value of 89.36091, which as estimated is 89 periods. So for this loan, we are going to need 89 periods or 89 monthly payments in order to pay off that certain loan. So the second function is called the PMT, which stands for payment. So payment describes the monthly payment that is needed in order to pay off a certain loan. So here, to demonstrate again, we have our given loan amount of 10,000, the interest rate of 5%, and then the months or the number of periods, which is 60 months. So to calculate the monthly payment, we just need to input the function PMT and then open parenthesis. So we just input the rate, also divided by 12, which is monthly basis. Next is the number of periods, which we don't need to divide to 12 because it is already converted into months, not years. So next one is the loan amount, and then simply close it and enter. So we have computed a value of 188 pesos and 71 centavos. So again, it is negative because negative stands for an outflow or a decrease, which that's what we always do when we pay loans. We decrease our cash. So that's it. So aside from computing the certain costs or certain payments on certain periods of loans, we can also compute for the depreciation of an asset. So to further demonstrate, we have here the straight line method or SLM as used in the function of Excel to compute for the straight line method of depreciation. So first, we have the given of present value of cost of an asset, which is valued at 10,000, the salvage value at 2,000, and then the useful life in years of 5. So to compute this, we just need to input the SLN and then open parenthesis. So as you can see, we have here the cost, salvage value, and then useful life. So put this in, and then next is 2,000 in B4, then next is useful life in B5. Then we close it, and that's our SLD depreciation. It's at 1,600 pesos per year. So second method for depreciation of an asset is the DDB or the double declining balance method. So double declining balance method uses the double of the straight line method, basically. So in straight line method, we have this formula, but in double declining balance method, we have all of these three: the cost, the salvage value, and the useful life, and the period by which we want to compute the depreciation of an asset. So this states that we can advancedly compute the depreciation of an asset for one period. So let's try it. Enter. So the DTB depreciation is totaled at 4,000 using the double declining balance method. That is for the first period, of course. So the third method of computing the depreciation of an asset is called the sum of the year's digits method. This method accounts for the depreciation of an asset through summing up all of the years or the useful life of that certain asset and then combining them to compute a final depreciation amount. So in this example again, so as compared to the DBB, we have 4,000 pesos as the resulting value. So if we compute for the SYD for one period only at the same input, we will get 2,666.67. So that is the difference between the double declining and the sum of the year's digits. So the next function that we will be using is the rate function. So this helps us to determine the interest rate of a certain loan or a certain investment. So to demonstrate, we have again the present value of a loan or an investment amounted at 10,000, the payment amounted at 200 negative, and then the number of periods or the number of months, which is amounted to 60. So in order to compute the rate, we just need to put the rate function and open parenthesis. We input the NPR for months, next is the payment, and then next is the present value, which totals at 1%. So that's simply how you calculate the rate of the interest rate of a certain loan or a certain investment. So another formula that is in connection to the rate computation is the present value computation. So we have here the given of payment of negative 200, the NPER or months of 60, and the rate of 1%. We will trace back now the present value. To do that, we just need to input the PV formula, then open parenthesis. We input the rate 1%, the NPER of 60, and then the payment of 200. Then close it and guess what amount we arrived. It is 8,991.01. So the next one is for the computation of the fair value of a certain investment. So to compute the fair value, we just need to input the FV formula, then open parenthesis again, then we input the rate of 5%, which is also divided by 12 because we always compute for the monthly basis. Then next one is the NPER of 60, and then the payment of 1,000. So we arrive at 68,006 pesos and 8 centavos. This next one is more commonly called as internal rate of revenue, or IRR in short. So we are computing the internal rate of revenue, as I said, from the preceding year's cash flows. So to demonstrate, we have here given from year 0, which we invested 15,000 pesos. Then the year 1, we got 2,900. Year 2, 3,4. Year 3, 3,5. Year 4, 3,6. Year 5, 2,9. And then year 6, 3,100. So to compute for the IRR, we just need to input the formula of IRR. And then open parenthesis. To select all of these values, we just slide down and then enclose them, so close parenthesis, and then there you go. We have an 8% internal rate of return. So the last one, but not the least, of the formulas used in the accounting profession under the Excel is the NPV, or also called as the net present value. So the net present value of an asset is a worth, or the value of an investment throughout its existence or throughout its lifetime, which is measured in today's discount rates. So to compute for the NPV, we have here the example by which we have the rate of 10%, and these are our matured cash flows. So first, as always, we need to input first the NPV, and then open parenthesis, then we input the rate, and then after that we are going to put in the year 1 to year 10, which is placed under the B3 to B12. After that, we are enclosing it to the parenthesis, and then we are going to add lastly the 200,000 from year 0. And that's where we arrive at our NPV of 45,782 pesos and 68 centavos. So that is all for my formulas, including in the accounting profession under the Excel. I hope that you have learned something, and I hope that this video has been productive for you. Thank you so much for watching, and I'll see you on the next one.